definitions of the following and use salt water as an example of each. Okay, so let's do this one. A solute is the substance being dissolved. Salt is the solute in salt water. Alright, a solvent is the substance doing the dissolving. Water is the solvent in salt water. Okay, a solution is the solute and the solvent together. Salt and water comprise the solution of salt water. Okay, and finally a solvate. That wasn't defined in the notes, so let's go over that. Let's talk about what that is. It's a solution, but in salt water would be an example of a solvate solution. It's when the dissolved particles of the solute bond to the solvent. So we've talked about how Na plus molecules and Cl minus molecules in salt will be broken off from a salt crystal and they'll bond to the water molecules around them. So that's called a solvate. So we can say this. Okay, so a solvate is a bonded complex of salt and water. So sodium cations and chlorine anions bond to water molecules. Remember, they do that through ion-dipole interactions. So that would be a solvate. Okay, now I'm going to give you a few number problems. I'm going to do every one of them for you. So stay with me. I'll show you how to do these. Okay, so we're going to do some calculations with molarity. So what is the molarity of 500 milliliters of a solution with 6 moles of potassium hydroxide? So the first thing you do is define what molarity is. Molarity, big M, equals moles of, in this case, it's always of solvent, so it's of KOH. Remember, you always write units of measure and what the substance is, per liters of the solution. Now you could write that as KOH plus water, but that's kind of long. So just call it solution and we'll abbreviate that SOLN. But we know when we see that, that means the KOH and the water together. Okay, now the reason you do this, you define what molarity is because you're really going to be working with these units, not with this unit. Okay, you eventually want to put it in unit of capital M, what is molarity, but when you're working with it, you want it in these units. So what we're going to say is we're trying to find the molarity. So I'm going to put right here, this is what we're looking for, and it's going to be mole of KOH per liters of solution. Okay, and what are we starting with? We're starting with 6 moles of KOH. So we're going to come way over here. So we have 6 moles of KOH on the top, and we want to end up with moles of KOH on the top and liters of solution on the bottom. So somehow we need to come up with liters on the bottom of this, because over here we have nothing on the bottom of this right there. Now here's the thing, we do have moles of KOH and moles of KOH, so our numerator, the top of our fraction, our final fraction, is already in the units we want. It's 6 moles of KOH. Somehow we have to come up with a way to get liters of solution down here on the bottom. Okay, well, it told us that there's 500 milliliters of this solution of 6 mole KOH. So we can put 500 milliliters down here. And it's of solution. Okay, so the top is good. We got to get the bottom to go from milliliters to liters. There's 1,000 milliliters per liter, and we need milliliters to cancel out and liters to be on the bottom. So here's our conversion factor. I'll write it up here first. 1,000 milliliters equals 1 liter. Okay, so what we're going to do is do this. And I put 5 there. Let me change that to 500. So 500 on the bottom. So we're going to do this. We're going to put 1,000 milliliters up here for every 1 liter. And always put units of measure, so it's milliliters of solution for every liter of solution. Now that relationship is true for anything, but in this case we're interested in the solution. We always want to be sure when we cancel, we're canceling the units and the proper substance. Okay, so milliliter solution cancels with milliliters of solution, and the only thing we have left on the bottom is liters of solution, which is what we want. So what we're then going to do is multiply 6 times 1,000, divide that by 500, and that's going to give us our answer, and that answer is going to be 12. So it's 12 moles of potassium hydroxide per liter solution, and the way you would really want to write that, the final answer is 12 molar. 12 molar is your final answer, okay? And that makes sense. Just think about it logically. If you have 500 milliliters is half a liter, and molar is how many moles per liter. So if you have 6 moles in half a liter, then in twice that much, 1 full liter, you'll have 12 moles. And that's what the answer is that we got. Okay, what is the molarity of 60 grams of NaCl dissolved into 400 milliliters of solution? So it's very similar to the last problem, except they've given us the initial starting amount in grams. So we're going to have to do a molar mass conversion. So we're going to come over here, and we're going to have some unknown number of moles of NaCl per liter of solution, SOLN. That would be salt and the water together. And we want to fill in that blank space. And we're starting with 60 grams. So we're going to come way over here on the left. So we're going to need to do another conversion. 60 grams per 60 grams of NaCl per 400 milliliters of solution. 400 milliliters of solution. Okay, so we need to build a bridge to get us from here to here. Well, first, milliliters to solution and liters to solution is just like the last problem. You're going to multiply, so you're going to do this. There's 1,000. Okay, so milliliter solution. So we end up with liters of solution on the bottom. That's what we want. So that part's good. Now we got to get from grams of NaCl to moles of NaCl. So you notice the strategy for this problem. You got a numerator and a denominator. You're going to end up with a numerator and denominator over here. You got to take one at a time. You can either work with the denominator first or work with the numerator first. In this case, I chose to work with the numerator to get it in the proper units of what the final answer is going to be. So we've taken care of the denominator. It's in liters of solution right there. Now we got to get from grams of NaCl to moles of NaCl. So what we need for that is the molar mass. Okay, so from the periodic table, sodium has a molar mass of 22.99. And chlorine has a molar mass of 35.45. And so we're just simply going to add those together to get the molar mass of salt. And that gives us 58.44. So what do we want to happen on the top? We want grams to disappear and moles to appear in the final answer. So we have this conversion, 1 mole of NaCl Okay, 1 mole of NaCl equals 58.44 grams of NaCl. So we want grams on the bottom because we need this to cancel out. So it's going to be 1. So the only thing we have left are moles of NaCl over liters of solution. That's what we want our final answer to have. So now we multiply 60 by 1,000 times 1 divided by 58.44 divided by 1 divided by 400. And we get 2.57. So the way to properly write the answer is 2.57 capital M for molar, which means moles of NaCl per liters of solution. Okay, that was a little tougher, just one more step though than the one above. I'm going to skip number 7. I won't go into why, we'll just skip that one. Let's move on, we just have one more to do. Okay, what is the molarity of an aqueous solution of 32 grams of NH3, that's ammonia, in 1.2 liters of solution? Okay, so again we're looking for molarity. Okay, so we have moles of NH3 over liters of solution, and what are we starting with? We're starting with grams of NH3, so we'll come way over here. Okay, so we start with grams of NH3 over 1.2 liters of solution. Now we look at where we're starting. Grams of NH3 over liters of solution, and what we need to end up with, moles of NH3 over liters of solution. So our denominator is already in the correct units. We don't need to change anything about that. Liters solution, liters of solution. The thing we need to do is change grams of NH3 into moles of NH3. For that, you need the molar mass. So 1 mole so 14.01 for nitrogen, 1.01 for hydrogen, and you have 3 of those, so that's 3.03. So that would be okay, so there's your molar mass conversion. We need grams to cancel out. That means the grams are going to have to go on the bottom. Okay, we don't have any more conversions, so we have a little empty space here. That's okay. So grams of NH3 cancel out. And we have moles of NH3 on the top, which is what we want in our final answer. And liters of solution was already on the bottom. So now you just have to multiply the numbers. Okay, so it's 32 divided by 1.2 divided by 17.04, and that gives you 1.56. And the proper way to write it is 1.56 capital M for molar. Okay, so that's it. That's just doing some of these. You can see this adds a little complication to doing stoichiometry. Once we get into a chemical equation, you have to know how to do these types of conversions as well, where you have two things mixed together, and you kind of have to learn how to just separate them out and get them into the proper units for the chemical equation. Okay, that's your assignment for Monday. I'll have a few more of these problems on Tuesday and Wednesday, and you'll be done with the class. So get everything done, including the old stuff. I've thrown out all the not accepted after dates. Just get things in. I just want people to pass this class and get through this and even get a good grade at it. So get to work in the next week, and you can get this done. You can do well. Okay, I'll talk to you again tomorrow.